Single variable data, histograms. Suppose we have the data set below, and we can see we're working with height, which is, of course, a continuous variable. We can produce a diagram of this called a frequency histogram. Note that this is not part of your course and definitely not recommended, but it will illustrate why we should use a histogram. So with a frequency histogram, we have frequency on the vertical axis and we just plot the bars. Because there is little data at the ends, the shapes that we see do not necessarily indicate the shape of the data overall. The gaps are a distraction. Where there is lots of data in the middle, we might be able to see more detail if we had the information. Suppose that we do have the extra detail. So where we have this in the table at the moment, let's suppose we had the information split more. Then we could order our table as shown below. So note where there wasn't much data, I've combined the groups, and then we've split the data in the middle. We now have unequal class widths. To compare, we produce a diagram on which the area of the bar represents the amount of data. In other words, we produce a histogram. The vertical axis has a quantity known as frequency density. Frequency density is equal to frequency divided by class width. So we need to bring in class width. We can see the first class has a width of 30. And then the next one is 10. Then we have some that have a width of 5. Then we have another 10 and a 30 at the end. We then need to compute the frequency density. So it's frequency divided by class width. So the first one is 5 divided by 30, which is 0.17 to 2 decimal places. Next one, 7 divided by 10, and so on. 4 divided by 5 is 0.8. We get 0.6, and at the end we get 0.07. So we're now in a position to plot this data. And the first bar corresponds to a class with a width of 30. Then we have a class with a width of 10, and then we have these ones that have widths of 5. And you can see when we've plotted this, it gives a much better overall impression of the data set than the one with the gaps at the end and just thick bars combining all this data in the middle. Since frequency density is frequency divided by class width, and we have class width here, the area of this bar is calculated by doing frequency divided by class width multiplied by class width, which gives us frequency. So the area represents the amount of data.